Okay. Let me get this going. Okay, here we go. Good morning, guys. Welcome to our last day of the week. Hooray. It's always nice when we have a short week, right? So let's see. Susanna has a question. Is Susanna in this class or in the other one? Okay, she's in 110 or 111. We don't care. Okay, cool. So last time we talked about moles, right? Let's have a look here. Let's do just a couple of practice to refresh our memories, right? We've already repressed them. We don't ever want to do them again, but they are very important. So, with this, let's just go ahead and, I don't know, let's say of 124 grams of sodium sulfate, let's say. We'll learn how to name those compounds later. But for right now, remember we're going to want to calculate the molar mass of the compound and use that to figure out the number of moles here. So go ahead, do it. And as always, if you guys have questions from last time, type them out. Let's see them. But in the meantime, go ahead, figure out for me the number of moles we have here. I will do it myself so I have the answer ready for you guys. Let's see. Do we even have anyone awake today? How about just a molar mass then? Do we remember how to figure out the molar mass? Poke. How do we do molar mass? There's one way to get me to stop asking. Good morning, Paulette. It seems you're the only one, alive right now. Everyone else is still asleep. Oh, fine. I can do the chemistry myself. We'll see how... It's okay. That's why we're here, Sherry, so we can go ahead and ask such questions. Yeah, how many moles are there in this particular mass of sodium sulfate? I want you to convert that number of grams into moles. Okay, so Ollie, I like your idea there. Yeah, we're definitely going to need a conversion here. So let me address one of those points real quick. So just so we are all familiar with how to interpret a chemical formula, this is 2 sodiums, 1 sulfur, and 4 oxygens. So you would, yeah, it's just like the water example. So with this, you would need to add up all of these guys. You would want to add up their atomic masses, right? So Ali, the 139 that you got there, I think might be slightly off because the one that I calculated was slightly bigger than that. Not slightly, it was like a little bit bigger, 3 grams bigger. Let's see. So you should have 2 sodiums plus 1 sulfur plus 4 oxygens, which will be 2 times 22.99 plus 1 times 32.07 plus 4 times 16. Again, those numbers are from the periodic table. When I did this, I got 142.04. I totally could have punched something in wrong, but go ahead, double check, see if I'm crazy. And remember, the units of molar mass could be either AMU. Yeah, no worries, Maya. I totally get it. The phone one is a bit harder to chat on, for sure. And so, this is the conversion factor we need. And so we're going to want to do 124 grams times 1 mole over that many grams. And when I did this, I got 0.873 volts. So hopefully, okay, cool. Good. Perfect. Okie dokie. Awesome. So, Sherry, if you still have a question about Avogadro's number, you can throw it in the chat. We can address it when you write it out. If not, we will. We're going to keep going. Alrighty, so there is a point to doing all of this stuff, right? Yeah. So we needed to find. Basically, right here, I've just asked us, this is just a unit conversion, right? We're going from grams to moles. That is a unit conversion. And for any unit conversion in chemistry, you need the conversion factor. And the conversion factor that will take you between grams and moles will be the molar mass. So, yeah, the first step of doing all this stuff, that gives us the molar mass, which is our conversion factor. And then after that, we can actually do the conversion, and then poof, we get our answer. Alrighty, so again, there is a point to doing all this stuff. Since we have already calculated our molar mass for this one, I want to show you what we can do with this information. More stuff we can do. So knowing the molar mass will let us determine the percent of each element. So, sodium sulfate, remember we just calculated 142.04 grams per mole. We could see how much of this compound is sodium, how much is sulfur, and how much is oxygen by doing the following. By using the masses of sodium as well as the overall molar mass. Let me just put molar in there so we don't forget it. And notice, because we have two sodiums, we're going to have to put that in twice. And then the molar mass we had already calculated. And since this is a percent, we always just want to multiply by 100%, because that'll give us type of percents we're used to seeing. So, if we go ahead and do that, 2 times 22.99 divided by 142.04 times 100 gives us 32 let's just do 4 sig figs percent sodium. So we're able to calculate that sodium sulfate, the compound up there, is about 32% sodium. And we can do the same with the rest of them. If we wanted to do sulfur next, it's exactly the same idea. We're going to do sulfur over the compound times 100%. So that'll be 32.07 over 142.04. Again, the numbers on the top I'm just getting from the periodic table. I just happen to have these memorized because we use them a lot, but you would presumably be looking them up. Totally normal. So doing this, 32.07 divided by 142.04. And from there we get 22.58% sulfur. And guess what? Doing with oxygen, same idea. Percent of oxygen is going to be our 4 oxygens over the whole thing, which would be 4 times 16 over 142.04. Is going to be whatever it's going to be. Let's see, 64 divided by 142.04 is 45.06%. Of course, because this thing only has 3 elements, if you find the first 2, you can find the last one by just subtracting from 100, right? They should all add up to about 100. There may be some slight, might be 100.01 or something, just some rounding errors, but these guys should add up to 100, so you can always find the last one by subtracting the other 2 from 100. And so we can see, we can use these percent compositions to do more fun stuff. Any questions on this one so far? Let me pull up that one. I suppose, Paulette. Oh, by the way, let's have a look at our Discord poll. Let's see how we're doing in terms of what type of exam you guys want. So it looks like right now multiple choice is winning. It doesn't look like we have a good amount of votes so far. So if you haven't voted yet in Canvas, there is I'm sorry, not Canvas, Discord, there is a poll for how you guys want to like handle the exam. It does look like multiple choice is the winner so far, but I'll keep this open till Friday. So if people want to still vote or change their vote or whatever, that'll be available. Alrighty. So while you guys are writing this down, any questions so far? It should say polls. What do you mean so many? There's like 4 for your class. There's not too many. Yeah, we do need to multiply by 100, yes. I just never write that usually just because like percent is always by 100. So anytime we're dealing with a percent, you should make it into a percent. So doing this, you'll get the decimal 0.4506 or whatever, multiply by 100 to get a percent form. But yes, technically we do that. So, okay, I can show you. Let me open up Discord here. No, apparently this computer doesn't even have it. No, you are right. I just was lazy. Don't want to write it every time, but I should have. So, go figure. Okay. Cool. So that is downloading. I'll open Discord on this. I'll show you how to get to the polls. So, okay. In the meantime, I'll just scroll down a little bit. Let's put this in a healthcare perspective. Oh, awesome. Okay. Yeah. So, but just in case anybody else doesn't know it, I will show you. Yeah. Okay. So, in the meantime, you guys start working on this one. So, I want the percent of sodium in sodium chloride. Let me grab my phone here because I have to use that to log on to Discord. Okay, let's see. So, Discord app, where are you hiding? There we are. Okay, so let's see. Where on earth is my QR code on this thing? Discord's always so mean to me. I have to do this. Let's see. There it is. Okay. Scan the QR code. And now it'll let me log in. Cool. I still want to show just in case other people have it. So, it's a good idea just for everybody. Everybody should be able to see it. So, okay, here we go. While you guys are working on that, I will show everyone else. Let me add a window capture for Discord. Where are you, Discord? Of course, Discord is like, no, I don't want to show up right now. Okay, forget it. We'll deal with Discord later. Okay, so hopefully calculating the molar mass should be easy by now. So you should get 58.45 44. Close enough. Okay, makes sense, Sherry. So the percent sodium should be 22.99 over 58.44 times 100%. And Sherry has said that it's going to be 39.3%, which makes sense to me. That seems pretty reasonable. So with that in mind, let's see what we can do with this number. So, like, what's the point? So there is a reason we're doing all this stuff. So let's say we have 5 grams of salt, right? So a recipe has told us, okay, we're going to put in 5 grams of salt. All right, and so let's say we are a hypertensive individual, high blood pressure, and so we are under, orders to kind of monitor our sodium consumption. And so what we can do with this information is we can say, okay, we know that 39.3% of sodium chloride is sodium, right? We don't have to monitor our chloride consumption, no problem there. It's the sodium we have to watch out for. And so by doing this, let's go ahead and do the math real quick. So 5 grams. So remember, when you're multiplying by a percent, you have to turn it back into the decimal. And so we're going to see that this amount of salt is going to be 1.9. I just lost the number because, okay, and 1.97 we'll say. So of the 5 grams of salt, we see that there's actually 1.97 grams of sodium in there. So that's pretty much like well above what this person should probably be having per day, but I guess adding 5 grams of salt to something would be a fairly significant amount. So from this, we're able to now use these percentages to apply them to quantities. So we can use this to figure out the percent of a particular element within a compound. And then if we wanted to find the mass of that element within a mass of a compound, we can use those percents in that way as well. Does that kind of make sense? So I'll try and put the homework up for you guys today so you can have a look at that, so you guys can practice with this fun stuff. And since it is going to be, okay, you know what, so it'll be due Sunday at midnight, and I will post the key at midnight, like right away, so you guys can check your answers before the next day. So you'll have some time to make sure that you are getting things correctly or to, double check stuff. Okay, cool. Yeah, I know. Paula, we all have the internet issues. My internet here, I think, is slower, so it's probably going to be some on my end as well. Alrighty. Any questions on this one? It'll be posted Sunday at midnight, so I guess that would be Monday at like 12:01 a.m. or whatever. So you guys will submit at 11:59, 2 minutes beforehand, and then the key will be posted like automatically after the due date for the homework. Make sense? So presumably after that, I put them on Canvas, I think. Can anybody else confirm just to make sure that I did it for your class? I hope I did. Okay, cool. Yeah, so there are answer keys for the homeworks up there, so you guys can check your answers. Just to make it clear, I will not be able to like print out all of your stuff and write on it and give individual feedback just because like that is a ton of work to print it all out. Normally, you know, if I were to collect homework from you guys, yeah, I would write on it and give it back to you. But with COVID, to do that and like individually scan them back to you guys, it's way too much work. So I will not be able to do that. So I will be putting the keys up so you guys will be able to double check your stuff. Okay, cool. Alrighty. So percent composition we've done. We can also go the other way. So that time we took a compound and we were able to figure out what the percents of each of the elements are within it. So way back when, historical times, when they discovered new compounds, what they would do is they would burn them and use like a special device to figure out the percent of each element based on different, you know, carbon dioxide or water or whatever products that were being produced from burning it. And they were able to figure out the percent of each element. And so we can do that in kind of the same way. I might have forgotten to put it for you guys. Let me just double check right now. Yeah, I totally did. I did not link it for you guys, so that is totally my fault. I will do that right now. They really need to like group the sections together so I don't have to do it individually for each one. Okay, I am so sorry about that. The keys are right here. So if you go on Canvas, there's going to be a brand new module for you guys that now has the keys to those two homeworks. I'm going to move it up a little bit. And I will also put up, what else did I need to put up? Homework keys are there. No, we're good. Okay, yeah, sorry about that. So cool, there we go. Homework keys are up, they're on Canvas. As soon as you log on your home page, it should be the second like box of stuff. So you'll see the stuff there. Cool. So let's go ahead and do kind of the opposite. So let's see, how do we find the formula of a compound from the percent of each element. So again, historically, this is how they would find out the formulas. We have kind of more advanced instruments nowadays to determine these things, but this is how they would do it. So let's say there was a compound that is 36.4% manganese and 21.2% sulfur and 42.4% oxygen. Okay, so these numbers would be given to you. So they were collected by some way of getting this data, and so it's been found out that this particular compound is made of these percentages of these three elements. And we can see here that these guys look like they will add up to 100, so they'll be the entire thing. When we're given percents like this, what we want to do is just assume we have a 100-gram sample of the compound. Okay, it doesn't matter. You could choose whatever number, but we're going to see, because these are percents, 100 is going to make the math easy for us, relatively speaking. And so what this means is if 100 grams is the compound and 36.4% of that is manganese, that means that we have 36.4 grams manganese, right? If the total is 100 grams, 36% of 100 is 36, right? So that's great. And we're going to do the same thing with all of our elements. And by doing this, we can easily just convert percent into grams. So far, so good, hopefully. Just assuming. It really doesn't matter because this is kind of a theoretical calculation, so it doesn't really matter what our mass is. If you really wanted, you could just leave these as decimals. Does not matter. We learned yesterday that because different atoms have different masses, right, different atomic masses, seeing 34 or 36.4 grams of manganese doesn't tell us how many manganese atoms we have. And in order to figure out, what's the ratio of manganese to sulfur to oxygen, what we're going to want to do is convert them all into a unit that we can compare. And that is going to be moles. So we're going to want to convert all of these guys into moles. So our first kind of step here was we are assuming that we have 100 grams of this. Again, you could choose any number, but 100 makes the math easy. And so we're converting percentages into grams. And our second step is we are going to convert these to moles. And so if we do that up here, we would want to bust out our periodic tables. We would find the elements we're looking at. So manganese is over here, number 25. We would see its atomic mass is 54.938. And with sulfur, I already know that one is 32.07 grams for 1 mole. These are just the atomic masses. How do we find the formula? Yeah, that is what we are doing with this one, Maya. So kind of this little section, I guess, is on how do we find the element or the formula when we're given the percentages. So just a few minutes ago, we were able to do the opposite. We had the formula and we're able to find the percentages. Now we're doing the opposite way. Okay, and then oxygen we're going to find on the periodic table as well. That's 16 grams per mole. Awesome. All right, and now I did this earlier. I have the numbers for us. Okay, good. 0.663 moles. 0.660 moles and 2.65 moles. Okay, cool. Yes, fun indeed. Because nobody likes to do this math, right? So with these ones in particular, I have to do them in advance because if I mess it up, it will not work. And I do not want to confuse you guys more than necessary. So, okay, so now, what the heck are we going to do? We figured out how many of each we have in terms of moles. So remember, moles are going to be an easy way for us to compare how many we have of each one, right? So we're now stuck with these numbers that don't seem very nice, but we're going to be able to figure out, the important part here is figuring out the ratio between these atoms. And anytime you want to find a ratio, you always want to divide by the smallest one, right? So if you have, a 4:2 ratio, that's the same as a 2:1 ratio. We're just going to try and find out what these 0.663 to 2.65 is. Let's try and find the ratio there. So it looks like here that this guy, let's just circle it in green. This is the smallest one. So let's go ahead and Oops, we do not need PowerPoint. Let's go ahead and divide by the smallest number for all of these guys. And doing this, we'll get about 1 to 1 to like slightly above 4. And so this is telling us that for every, let me just write this part that we did, where we're then going to divide by smallest number of moles. And so all of this stuff tells us that we know our compound is made of manganese, sulfur, and oxygen, right? It's the 3 elements in our compound. We might as well just put them in that order. And so what these tell us is that for every 1 manganese, we have 1 sulfur, and for every 1 manganese, we have 4 oxygen. So that's going to tell us we have a ratio of 1 to 1 to 4. And since in chemistry we just don't really write the ones, we are just going to make this MnSO4. And so we'll be able to identify this particular thing. All right, and so this is what's called the empirical formula. An empirical formula means the smallest ratio of atoms. All right, and just so we're clear, like this is kind of the step 1 we did. This was step 2. This was step 3. And then we put it all together at step 4. So when you're looking at the later, I know, like, unfortunately, like, the screen is smaller than I would like. You know, if we were in a regular classroom and I had a big old whiteboard or something, it'd be real nice, but we just have to scroll back and forth. So doing this, we did these four things to figure out the empirical formula of this compound. Okay, before we go ahead and do another one, I'll give you a few minutes to write here if you need. Do we have any questions on this particular process? So remembering that grams are not a way that we can compare different elements, but moles are. So remember, moles will tell us, okay, from this formula we can see we have 1 manganese, 1 sulfur, 4 oxygens. And we're going to see all of those would weigh different amounts, right? Because different atoms have different masses. And so we're using the idea of moles to be able to figure out how many of each one there are with respect to each other. Okay, so let's do another one then. Okay, cool. Yeah, let's do this one. Okay, let's do another one. We'll just use the same elements. Yeah, of course. Is that far enough? Sorry, I had to look at my notes too for our next problem. So. Is this far enough? Okay. Yeah, I think you might be thinking of magnesium sulfate, MgSO4. That can go in a drip line, but typically manganese you would not want to. Because I think this is a healthcare thing. Like magnesium sulfate also will, so that's the same as Epsom salt. So you can use magnesium sulfate for, bathing in if you've got sore muscles or whatever, or if you want to give yourself diarrhea, you could eat a lot of it. So fun. Yeah, so sometimes, and it could be a good source for magnesium as well, like for migraines or something like that. So, oh no, yeah, not for plants. Yeah, for people. Yeah. Okay, cool. Yes. So we're going to see that a lot of the stuff that we work with here, of course, has real life applications. So, okay, cool. So, let's do another one with the same elements. Let's say we had 27.6% manganese this time and 24.2% sulfur, and again that 42.4. Wait, are these exactly the same? No. Okay, good. Percent oxygen. No, I lied. 48.2. See, I got confused. Okay. Yeah, there we go. Okay. Oh, interesting. Consider gallstones, so it must chelate the cholesterol or something. So, okay, cool. So, step 1 is convert to grams, right? So, we can go ahead and do that. 27.6 grams of our first element, 24.2 grams of our second element, and our third one. Okay, nothing too crazy there. Step 2, we're going to convert them all to moles. I'm just going to scroll up to get that atomic mass of manganese again, so 54.938. And again, I'm able to do this super quickly because I have these already in my head. So just remember, like I'm going to just put a little star. These guys are from the periodic table. Okay, just so we remember where the heck those numbers have come from. Those are from the periodic table. Okay, doing the numbers. Let's see, we're going to get 0.503 and then 0.754. I'll put the 0 there, and then actually this one's going to be bigger, right? Yeah. So these were all the moles, right? Yeah, the atomic weight. Third step was we want a ratio, right? So we have to divide by the smallest number. And so with this, our smallest number is 0.503, right? That's the smallest of those three. And doing that, we're going to get 1, 1.5, and 6. So, looking at this, could we just put it as, oops. Yeah, it's always grams. So the units of atomic mass are grams per mole. So the mole will be on the opposite side of the grams. The number from the periodic table will always take grams. All right. If you were to do this, I would be angry. We don't like this. Nobody does formulas with a 1.5 in it. However, like, we are definitely not going, so Paulette, we're not going to want to do that in this case. Because if we round up to 2, we're going to end up with a different compound. So that would work if this were a calculation problem. Yeah, we would round up. That's what sig figs tell us to do. But this is the ratios here. We want to know, we know for every 1 atom of manganese, we have 1.5 sulfurs. And so this is not going to be useful to us right now, but what we can do is make these into integers. And how we're going to do that is, in this case, we're going to multiply by a number, in this case 2, to make them into integers. And so we're going to end up, we see that a number was 1.5, right? The ratio of 1 to 1.5 is the same thing as a ratio of 2 to 3, right? It's the same numbers ratio-wise, but whenever we're dealing with a formula, we always want to have integers. So if we see that from our ratio we end up with a decimal number, instead of rounding, for which one, I'm sorry? You might be using a slightly different atomic mass. I can do it one more time just to be sure, but 27.6 divided by 54.938. I got 503, yeah. So just double check your calculator, I think. Of course, no, I totally understand. Yeah. So that's why I did the math already. Like, I trust you guys can throw in numbers onto your calculators. So, like, that part we don't have to worry about, hopefully. Because that's just plug and chug, right? But the important part I want us to understand here is the process that we're doing and how we're going to deal with these ratios. Yeah. But I totally understand. Yeah, this is new stuff, and it totally is fast. So, but such is chemistry. So, unfortunately, it will be a fast thing. So that's why we're going to keep doing these. More and more practice. Cool. So I'm going to have some handy-dandy rules for us here. By the way, this one makes me happy because we always want to have integer numbers, right? So that's going to give us a nice ratio between all of our elements. So, oops. So if your ratio has a decimal, just like our last problem did, we're going to see that if your number had 0.5 in it, oops, decimal, okay. If your thing had 0.5 in it, you're going to want to multiply everything by 2, right? That will get rid of any 0.5s you have, and that will turn everything into integers. Sometimes you're going to see that maybe you're going to end up with something that has 0.33 as your ratio. And what you're going to want to multiply that by is 3. So I'm just giving you a little resource guide. So we're not going to round our ratios. We're going to want to multiply everything by an integer to make it happy and nice and even for us. If you were to get 0.25, you would multiply by 4. Or 0.2, you would multiply by 5. Okay, and same thing going the opposite way. You know, if you were to get something like this, you would just multiply it to cancel out the decimals. And just so you know, we are going to multiply all ratios by these. And what that means is, with this, we can see that maybe we have a ratio of 1.33 to 2 to, I don't know, 4. I'm just going to make this compound up. Carbon and, let's not use carbon, let's see. How about whatever, potassium, who cares? If we see that we have a 0.33 in it, like this decimal, we're going to need to multiply all of these by 3, right? Because that's what the chart will tell us to do. So if we were to do a problem that gave us these ratios, we may need to multiply our number. And so as a result, 1.33 times 3 is going to be 4. 2 times 3 is 6. And 3 times 4 is, oops, oh no. What is 3 times 4? 12. Okay, and then we would do it that way. And then we could say, okay, we've got whatever this was, whatever this thing happened to be. Okay, so if you get a integer, don't say, okay, I'm just going to round that down to 1. If you do that, you'll get the wrong answer. What you're going to want to do is see what your decimal part is and multiply by the corresponding number to kind of get rid of it. All right, does that make sense? Yeah, exactly. That's the idea. So technically, like, presumably on your thing, like, if it's within, like, 0.05, that's probably just due to rounding or something. That's okay to round. Like, 3.99 is 4, yeah. Yes, all of them have to be multiplied, because remember this is a ratio. So if we're going to multiply one number, we have to multiply all of them. Exactly. So we would have to multiply everything by 3 in this case. Yep. Definitely Maya. Okay, cool. So there is one more part to this, but I don't want to throw that at you yet, I think. So when I'm writing your exam, I'll just make sure not to include that part yet. Okay, so in that case, do you want to do like one more problem, or what would you like to do? We could just kind of end now, or we could do another one. I don't want to go to the next stage of this, just because that would probably cause more confusion than help. Oh, by the way, also something cool about. Okay, we'll do another one. One thing that's pretty cool about Twitch is if I am going too fast, you can pause the live stream, and it'll just resume where you left off. So if I am, yeah, we'll do one more. So you can always just pause it, and then you can resume it once you're ready. So if I am going too fast and it's hard to stop me, you can just throw something, or you can just pause it. So, okay, let's see. So okay, this one I am gonna have to calculate. Yeah, so you can totally pause it and then catch up later. However, that would probably like mess up the chat part, but unfortunately, there's no way to ever win, right? You can't like actually slow down time. Okay, the last problem. Oops, I don't need that. Okay, here we go. Let me see here. Let's do this one. So it is 28.73% potassium, 1.48% hydrogen, 22.76% phosphorus, and 47.03% oxygen. What do you mean post them? Like the videos or homework? If it's videos, I usually do it like as soon as class is over. So the 111 class they start at 10:15 and end at 11:15. So I usually post the videos. I'll upload them around 11:20 or so. And then, so it takes maybe like 5 minutes for me to download the videos, and then probably another like half hour for YouTube to upload them, and then maybe some more time for processing or whatever. So YouTube, maybe they'll be up there by like 1 o'clock. But if you go on Twitch, you can see them pretty much as soon as I'm done. Like right at 10 o'clock, the Twitch video will be available for you to watch. And they're the same video. But Twitch sometimes needs a little bit stronger internet. Tammy, in terms of homework, yeah, I will be posting homework for you guys later today. I have to write the homework, so this one I don't have a fancy worksheet for us, so I will be writing your homework and then I'll be uploading that to Canvas. Okay, cool. So since we just have a few minutes, let's go ahead and do this. If you have more questions, go ahead and put them in and we'll address them as necessary. Oh no, already I've made a mistake. Okay. What was it? 22.76 grams phosphorus and 47.03 grams oxygen. So hopefully this part does not have any questions. Just make them into grams. Hopefully should not have any problems doing that. Step 2, we want to convert them all to moles. I know some of these off the top of my head. The others I will look up in this handy-dandy periodic table I have here. Potassium is 39.1. And phosphorus is 30.97. Okay. And all of these, of course, 1 mole on the top. And this one I have not done ahead, so I'll do them now. So you guys can do them at the same time, which is always awesome. That'll force me to slow down. Ollie, we are assuming it's 100 grams. It doesn't matter what you assume it is. You can assume it's 1 gram. You can assume it's 1,000 grams. As long as your percentages correspond to the number you choose, it'll work. So it's just easiest to assume 100. Because these are percentages, so it really doesn't matter what mass you choose, because it'll be the same for whatever mass you choose. right? So if you choose 10 grams instead, 28% of 10 will be 2.8. So you would just use those numbers instead. It'll still work, trust me. But easiest to do 100. Okay, hopefully I answered that. With this one, we get 1.468. 22.76 divided by 30.97 gives us 0.7349. And the last one, 47.03 divided by 16 gives us 2.939. Okay, so hopefully all of these, again, just from doing the calculations. So we would divide them all by the smallest, which looks to be 0.7348. These two are going to be 1. Looks like this one's going to be 2. The other one I cannot do in my head so easily. 2.939 divided by 0.7348 is 4. And so this tells us we have 1 potassium, 2 hydrogens, 1 phosphorus, and 4 oxygens. So we'll just assemble that. And we'll use purple because why not? So we have K, H2, P, O4. So thankfully with these ones, the math worked out nicely. Excuse me. And so in this case, we did not have any crazy decimals that we needed to use that chart above to multiply by. So these ones worked out nicely. So this one is not necessarily medicine related. This one is understanding how we get formulas, or how we used to get formulas. So if you were, a chemist in the 1600s or whatever, you were burning these things and using what came out of burning them to figure out their percentages, and then from there you would figure out the formula. So this is really just kind of explaining how we understand these formulas are this way. Okay, cool. So, looks like that is it for today. So, again, the poll will close on Friday. So vote if you want to. If you have any questions, as always, throw them out in Discord. I will try and upload your homework later today. As soon as I can write it, so you'll have, through the weekend to work on it. And as always, feel free to ask each other questions in Discord, and I'll be, there as well to answer them if necessary. Okay, so with that, see you guys. Since Monday is the exam, by the way, I'm not going to stream, obviously, because there's no point, because you'll just do your exam on Monday. Whatever format we choose, that depends on the poll, Maya. So the poll will be to choose multiple choice or the other way. So I'll send out an email of how that's going to work, but I will not stream on Monday because that'll just be the day you do your exam. Okay, so I will see you guys then on Tuesday, and we will finish this last little bit up, and then we will move on to Chapter 4. Exciting. Okie dokie. Okay, see you guys. Study well, stay safe, and have fun.